In this video, I will show you how to factor polynomials using a combination of greatest common factor, box method, and difference of squares. Alright, for the next couple problems, we need to factor using the GCF first, and then the box method or grouping, etc. We're just going to do the box method. But we have to do the GCF first, greatest common factor. Let's see. All of these are divisible by 3, and they don't all have a variable. So 3 is the greatest common factor. So I'm going to pull that off to the side. Alright, then I will use some parentheses to hold the leftovers. To figure out what goes inside the parentheses, I will divide by my GCF. Alright, so that's going to make 2x squared minus x minus 10. But we don't stop here. We pulled out the GCF, and that's great. So now we need to look at this red trinomial and do the box method. So we're going to go back to this business. We need a product and a sum. The product has to be a times c. So 2 times negative 10, which is negative 20. The sum has to be the b value, which is negative 1. Okay, let's start with the product. 20. Okay, what multiplies to make 20? Well, 1 and 20, or 2 and 10, or 4 and 5. Alright, that's it. These are all of the ways to make 20 using multiplication. Now, switch your brain to addition. Which of these pairs can make a negative 1 by addition if we choose the signs right? Well, 4 and 5. Okay, so 4 and 5. To make negative 1, we need a positive 4 and a negative 5. That would make negative 1. So let's see. If we do a positive 4 and a negative 5, multiplication, okay, that's negative 20, which is what we wanted. So these are the numbers that we're going to use. So we can go ahead and do the box method. We can make the box now. Okay, so the box is going to be just like this. Alright, in the first square, we will put the first term, 2x squared. In the last square, we will put the last term, which is negative 10. In the other two squares, we are really splitting up the negative 1x into two terms, 4x and negative 5x, which we got from the whole product sum discussion. So I will put those two terms right here. So 4x and negative 5x. Now we will do the GCF of every row and every column. So the GCF of the top row is x. The GCF of the bottom row is positive 2. The GCF of the first column is 2x. And the GCF of the second column is negative 5. Now, I'm calling it negative 5 because the first term is negative. This will give us a binomial times a binomial. From the left, I have x plus 2. And across the top, I have 2x minus 5. However, this is not the final answer because there was a GCF that we pulled out right at the beginning. That GCF is still part of the answer, so this is the final answer. This is interesting. Looking at these numbers, I don't see a single number that divides into all three of these. So there is no GCF other than 1 as far as 25, 20, and 4 go. However, all three terms have variables. So that's why there is a GCF. It is just x. I'm going with the smaller amount. So, once I pull that x out, I'm going to have to put the leftovers in parentheses. To figure out what goes inside, I will divide by my GCF. So then I realize that what I have is 25x squared minus 20x plus 4. That's what's left. So it is time to factor this red trinomial. So I'm doing the box method, so here I go. We will need a product and a sum. The product has to be A times C. So that's going to be 100. The sum has to be the B value. So that's going to be negative 20. Okay, now I'm sure I could go through this. 100 is small enough that I could do my multiplication facts. I'm wondering, should I mention the calculator trick now? This is probably my best opportunity. I'm going to go ahead and show you the calculator trick. Okay, every now and then you get a large number for the product. And if you're afraid you might miss a number when you make your chart, that's why you would do the calculator trick that I'm about to show you. The calculator will basically make the table for you. So you know how we always make this table starting with the product, and we start off with 1 times the number and then we go from there. So here's how the calculator will do it for you. If you hit the table button and then you type in the number divided by x, so I'm going to go 100 divided by x. Okay, I like to start at 1 because that's going to give me 1 times 100, so I'm going to start at 1. Okay, so you see I have the 1 and 100, then I have 2 and 50. Okay, ignore the decimals because we're looking for whole numbers. So I see 4 and 25, 5 and 20. All right, decimals, 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 and finally 10 times 10. All right, so the calculator can give you the list. Now, which pair can add up to negative 20 if we pick the signs right? Well, it looks like just 10 and 10. Okay, 10 and 10 will add up to negative 20 only if they are both negative, negative 10 and negative 10. So then we have to do negative 10 times negative 10, which does make positive 100. So this is the pair that we're going to use. So time for the box. In the first square goes the first term, so 25x squared. In the last square goes the last term, so 4. In the other two squares, we are going to take this negative 20 and split it up using the two numbers that we just found. So instead of having negative 20, we will have negative 10x and negative 10x, which we will write here and here. Now we will do the GCF of every row and every column. So the GCF of the top row is 5x. The GCF of the bottom row is negative 2. I'm calling it negative 2 because the first term is negative. The GCF of the first column is 5x. And the GCF of the second column, again, will be negative 2. And again, whoops, I put an x. Again, I'm calling it negative 2 because the first term is negative. This will give me a binomial times a binomial. Okay, I have 5x minus 2 from the left, and I have 5x minus 2 from the top. However, because there was a GCF right at the beginning, this is not the final answer. We must include that common factor in the final answer. Alright, for these problems, we are to factor each polynomial completely. None of these polynomials are prime. You might use greatest common factor, difference of squares, or the box method / grouping method, or a combination of these methods, but none of them are prime. Always look for a common factor before you do anything else. So on this problem, I see that 20 and 5 are both divisible by 5. So there's definitely a 5 in the common factor. Now I'm looking at the variables. Both terms have a's. They both have at least one a. In other words, I use the smaller amount. They both have b's. They both have one b, so I'm going to use b. So there's my GCF. Now if I take this out, that's going to leave some leftovers behind inside the parentheses. To figure out what goes in there, I need to divide by my GCF. Divide by 5ab. So let's see, 20 divided by 5 is 4. A to the third divided by a is a squared. And the b's cancel out. And then minus. Look, everything cancels out, but it's not going to just be nothing. Something divided by itself is 1, so this is going to be a 1. Now the question is, am I done? Well, look at the parentheses. Can this be factored further? Since this is a binomial, and we've already taken out the common factor, the only way this is going to factor is if it is the difference of squares. Well, it is a difference, subtraction. 4 is a perfect square, a squared is a perfect square, and 1 is a perfect square. So this is the difference of squares. So we must keep going and use the difference of squares pattern. 4 can factor evenly by doing 2 times 2. A squared can factor evenly as a times a. Then we have 1 plus and 1 minus. And 1 can factor as 1 times 1. So there's your difference of squares. Meanwhile, the GCF stays in the front. So 5ab. And here is your completely factored answer. Again, look for the GCF first. So these are both divisible by 2. And that's it. So the GCF is 2. Now that's going to leave some leftovers in the parentheses, but to figure out exactly what that is, I need to divide by my GCF. So that's going to leave 12x squared minus 75. So the question is this the final answer? Well, look in the parentheses. Can I factor any more? Well, this is a binomial, and the GCF has already been taken out. So my only hope is difference of squares. Well, guess what? 75 is not a perfect square. 12 is not a perfect square. So this is not the difference of squares. So that's it. That means we're done. So this is the final answer. Let's see. Common factor. All of these are divisible by 2. That is the only number, so that's going to be my GCF. And now I have to think what's left behind. To determine what's left behind, I divide by the GCF. So that turns out to be 4x squared minus 4x minus 3. So, am I finished, or can I factor this further? Well, I see this trinomial. If I'm going to factor this, it's going to be the box method, or grouping, but we're using the box method. So let's try. So when we do the box method, we always start off with this, a product and a sum. The product has to be A times C, so that would be negative 12. The sum has to be the B value, so that would be negative 4. Okay, we start with the product of 12, and we ask ourselves, what multiplies together to make 12? So that would be 1 times 12, or 2 times 6, or 3 times 4. These are all the ways to make 12. Now, which of these pairs can add up to negative 4 if I pick the signs right? Well, that's the 2 and the 6. These can make negative 4 if I have positive 2 and negative 6. Okay, so which means I have to do positive 2 times negative 6, which does make negative 12. So this is working for us. So that means we can go ahead and make the box now. In the first square, we put the first term, so 4x squared. In the last square, we put the last term of negative 3. Okay, for the other two squares, we are going to take the middle term and we're going to split it up using these numbers. Okay, so instead of writing negative 4x, we will have 2x and negative 6x, which I will put here and here. Now we find the GCF of every row and every column. The GCF of the top row is 2x. The GCF of the bottom row is 1. Nothing divides into both of these, so it's just 1. The GCF of the first column is 2x, and the GCF of the second column is negative 3. Notice I call it negative 3 because the first term is negative. This gives me a binomial times a binomial. I will have 2x plus 1 from the left, and I will have 2x minus 3 from the top. However, do not forget about the GCF that we pulled out at the very beginning. That belongs in the final answer. Okay, GCF. Well, both of these are divisible by 8. So I know 8 is going to be part of this GCF. Variables. They both have x's. The lesser amount is just x. They both have y's. The lesser amount is y. Well, who am I kidding? They both have exactly one y, so that's how many I pull out. That's going to leave some leftovers in the parentheses like you do. To find out what goes in the parentheses, we divide by the GCF. We divide by 8xy. Okay, so the 8's cancel out completely. X to the third power divided by x is x squared, and the y's cancel out completely. So I have plus. 72 divided by 8 is 9, and the x's and y's cancel out completely. So I just have this. Now the question is this the final answer, or can I keep going? Can I factor this further? Well, I cannot factor this further. If this had been subtraction, this would be the difference of squares, and then I could factor it as x plus 3 times x minus 3. However, it is not the difference of squares. It is the sum of squares, which cannot be factored. So this is the final answer. Okay, GCF, GCF, GCF. Well, this first term has like a 1 right here. So there's no number that's going to divide into all of these. So variables. Do they all have x's? No, the last one has no x's, so forget about that. Do they all have y's? Yes, they all have one y. So that means y is the GCF. So I'm going to have parentheses to hold the leftovers. And to figure out what the leftovers are, I simply divide by the GCF. So that's going to make x squared minus 3x minus 18, as all the y's cancel out. Is this the final answer, or can we factor this more? Well, there's only one way to find out, and that's to try to factor it. So, box method. We need a product and a sum. The product has to be a times c, so that's negative 18. The sum has to be the b value, which is negative 3. Let's start with the product. Let's just call it 18. Forget the negative sign for now. What multiplies to make 18? Well, 1 and 18, 2 and 9, 3 and 6, 4, 5. That's it. These are the only ways that you can make 18. Now, can any of these pairs make a negative 3 if I add them, if I choose the signs right? Well, 3 and 6. Let's see. To add up to negative 3, I need a positive 3 and a negative 6. So, what about multiplication? 3 times negative 6 is negative 18, so this is looking good. Let's make the box. Alright, the first term is x squared. So that goes in the first square. The last term goes in the last square. The other two terms come from the middle term. I'm talking about the other two squares. But the middle term is going to be separated into two terms using the two numbers that we just found. So negative 3x will become 3x and negative 6x, which I will write here and here. Now, let's find the GCF of every row and every column. The GCF of the top row is x. The GCF of the bottom row is 3. The GCF of the first column is x. And the GCF of the second column is negative 6. Notice I go with negative 6 instead of positive 6 because the first term is negative. This gives me a binomial times a binomial. From the left side, I have x plus 3. From the top, I have x minus 6. Now, this is not quite the final answer, though, because we took out a GCF of y in the very beginning, and that must be put and included in the final answer. 4, 12, 9. What divides into all of these? Nothing. What about variables? Nope, no variables on the last term. So, there is no GCF on this problem. But that doesn't mean it's unfactorable. So, we just move on with the box method. So, for the box method, we need a product and a sum. The product has to be a times c. So that's going to be 36. The sum has to be negative 12. Let's start with the product, 36. What multiplies together to make 36? Well, 1 and 36, 2 and 18, 3 and 12, 4 and 9, or 6 and 6. Okay, that turned out to be a pretty involved list for considering how small this number is. It might have been fun to use the calculator trick. Let me just remind you of that one more time. If I wanted to use my calculator to make the same list, I would just put in 36 divided by x. I would start at 1. Just hit enter until you see a table. Okay, and notice how this matches what I wrote down. 1 and 36, 2 and 18, 3 and 12. Let me scroll down. Okay, 4 and 9. Ignore the one with the decimal. 6 and 6. Alright, the calculator will just generate the table for you if you ever need it. Now, which of these pairs can add up to negative 12 if I pick the signs right? Well, 6 and 6 can do it. Alright, just double checking if there's anything else. 6 and 6 will add up to negative 12 if they are both negative. That means we'd have to do negative 6 times negative 6, and that is positive 36, which is what we wanted. That means we're doing great, and it's time to make the box. In the first box, we put the first term, 4x squared. In the last square, we put the last term. In the other two squares, we are going to take the middle term and split it up into two terms. Okay, and that's what we will put in these last two squares. So we will have negative 6x and negative 6x, which I will write here and here. Notice that together they make negative 12x, just like we wanted. Now we do the GCF. The GCF of the top row is 2x. The GCF of the bottom row is negative 3. Notice I call it negative 3 because the first term is negative. Similarly, the GCF of the first column is 2x. And the GCF of the final column is again negative 3. Again, because the first term is negative, it has to be a negative GCF. This gives me a binomial times a binomial. From the left, I have 2x minus 3, and across the top, I have another 2x minus 3. Now, I did not take out a GCF, so I don't have to worry about including a GCF in the front here. So this is the final answer. Because these happen to be the same thing twice, I could also write 2x minus 3 squared if I want it to be fancy. Alright, we're down to the last three problems. For this set, only one of these polynomials is prime. Alright, meaning only one of these cannot be factored. We are supposed to circle the one that's prime and factor the others. Okay, one of these is prime. Maybe it's this one. I don't know yet. First thing you do is look for a GCF. Alright, there's no GCF on this problem. So, because this is a trinomial, that means we're going to do the box method. So, let's go ahead and try. Now, it might be prime, so, be careful. But for the box method, we have to do product and a sum. The product will be a times c, so that's going to be 30. The sum is the b value, so that's 13. So let's make our list starting with the product of 30. What are all of the ways to multiply and get 30? Well, that would be like 1 and 30, or 2 and 15, or 3 and 10, or 5 and 6. So these are the ways we can multiply and get 30. Now, let's switch our brain to addition. Which of these can add up to be 13? If we pick the signs right. Well, there are two of them that can make 13. let's just look at one at a time. Look at the 2 and 15. Say if I went with that, 2 and 15. In order to make 13, I would need a -2 and positive 15. Okay, great. But that means I would have to do -2 times positive 15, but that's wrong. That would make -30, not positive 30. So that means this one didn't actually work. Alright, so let's try again with the 3 and the 10. Okay, so 3 and 10. In order to make 13, I would just leave them positive. So then I would leave them positive for the product as well. And 3 times 10 is positive 30, so this is great. So it does not look like this one is prime. Okay, if none of these worked, then we would have said prime. But we found a working pair, so let's go ahead with the box method. In the first square goes the first term, so 2x squared. In the final square goes the final term, 15. For the other two squares, we're going to take this middle term and split it up using the two numbers that we just found. So instead of 13x, we will have 3x and 10x, which I will put here and here. Now we will do the GCF of every row and column. The GCF of the first row is 2x. The GCF of the second row is 3. The GCF of the first column is x, and the GCF of the second column is 5. So this gives me a binomial times a binomial of 2x plus 3 from the left and x plus 5 from the top. Since there was no GCF at the beginning, this is the final answer. Alright, still looking for that prime one. Now, I'm cheating and I'm looking ahead at 13C, and I can see that this has a common factor. 4. 4 divides into both. So there's a GCF. That means this one's not prime. That means 13B must be prime. So really, based on that, I could circle this right now and say prime. Alright, they told me to circle the one that's prime, so I circled it. Now, say if I didn't look ahead and notice. How would I know that this is prime? Well, I would try to factor it and fail. So let me show you what that would look like. Well, it's a trinomial. There's no GCF. So I would try to do the box method. So I would say I need a product and I need a sum. The product has to be A times C. That's 1 times 5, which is 5. The sum is the B value, which is 10. We start with the product of 5. What are all the ways to multiply and get 5? Well, 1 and 5, and that's it. Okay, and then we ask ourselves, can we take these this pair and make it add up to 10? Okay, well, 1 and 5. No, there's no way we can make choose the signs so that it will add up to 10. There's no possible way. So that's how we know it's prime, alright? Because there is no product and sum. There's no way to make 10 and 5, product and sum. Anyway, let's move on to 13C. As I mentioned, this has a common factor of 4. So we will definitely pull that out. That's going to leave some leftovers inside parentheses. And the way I know what goes inside is I will divide by my GCF of 4. So that's going to leave me with x squared plus 25. So the question is this the final answer, or can I factor this further? Well, if this had been minus 25, then this would be the difference of squares, and I would go x plus 5 times x minus 5. But this was not minus 25. This was plus 25. This is not the difference of squares. This is the sum of squares. And the sum of squares cannot be factored, which means this is the final answer. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.